Often I'll get students with some rough carpentry experience, and they're used to just driving screws right through things, such as this OSB and softwood 2x4. But then they try and apply that same concept to, in my class, with hardwoods, and they try and drive the screw through, and you can see they get splits like this. So what I'd like to do is show you a quick process and how to avoid splits like this. So let's say I'd like to join these two pieces of wood using this screw. How can I do so without splitting either piece? We'll follow these steps. I'll go through them briefly now, and then I'll explain in detail each one. First, we're going to bore a through hole, the major diameter of the screw, through the top piece. Then we're going to countersink the diameter of the head into the top piece. Then we'll bore a pilot hole, the minor diameter of the screw, into the piece that the threads will go into, and then we can drive the screw. So step one is to bore a through hole, the major diameter of the screw, and that goes through the top piece. So it's a through hole, it goes all the way through. The major diameter, as you can see in this diagram, is the outside dimension of the screw, so the outside to outside of the threads. And the screw that we're using with this bit, the outside diameter of the screw matches the bit diameter. So I'm going to bore this hole, and then I'll show you how the screw can pass right through. So if it's done right, you should be able to take the screw and it can slide right in. Now there shouldn't be play, because then it will not keep the pieces in place. But the screw should be able to slide right through without engaging the threads. Step two is to countersink the head diameter, as noted here. So you need to make sure a countersink bit is at least as big as the head diameter. And we're going to go until the screw head could be flush with the board. So we can check the screw head, make sure it fits in. Now, if we wanted to hide our screw head, we could always bore our countersink down deeper, and then we could plug the hole. So now we could bore out a plug, and we could fill that hole with a plug, and then it could be a decorative piece as well. But many times we'll allow the screw head to show, so then we just need it to be flush. Step three is to bore a pilot hole, the minor diameter of the screw. The minor diameter from the lower portion with the threads, from inside to inside, excluding the threads themselves. So when looked at on the screw itself, when we put the bit in front of the lower portion of the screw, we should cover up all of it except the threads. Now when you bore this hole, make sure everything's lined up, because this will be how the parts line up when you assemble the screw, or assemble the parts with the screw. And there's step three. Step four is to drive the screw itself. Just make sure before you do so that you have your ratcheting features set so you won't split out this board. So just line everything back up how it was when you bore your pilot hole. Make sure everything's tight. Assembled nice and neat. So in this case, we were using a traditional wood screw that has this wider portion near the head. But many times you may be using more of an all-purpose screw or a drywall screw where it doesn't have that portion and the threads are the widest portion. So in that case, we can actually take out the first step if we're not concerned about the threads themselves splitting out our top board where we normally have that through hole. So now we can just bore our pilot hole all the way through for the shank diameter, and then we can countersink, and then we can drive the screw. So let me just demonstrate that. So this is the bit for the pilot hole. and we can countersink, and you can actually get countersinks where that pilot hole bit is fastened within the countersink. And then we can simply drive the screw. So that's just an alternative if you're not using a traditional wood screw, if you're using more of a general purpose screw.